Hello and welcome everyone. Welcome. Thank you for joining our webinar. Today's topic is how to achieve 100% regression test coverage with diagnostic simulation. My name is Lukas Katzenwadel. I'm Key Account Manager at Softing Automotive, and today with me is my colleague Dirk Pavels. So Dirk, just take a moment to introduce yourself, please.
Yeah, hello, my name is Dirk Pavels. I'm here by Softing working as a test engineer. I'm a product owner for our diagnostic simulation solution for the TCS, test tube simulation in third generation.
All right, thank you. So let's step right in. The agenda for today, we are going to talk about some diagnostic use cases at first. After that, we will have a look at some potential issues that may arise. And after that, we will see our solution concept in detail. And after that, we can show you how the simulation can be used. And we have prepared some live demonstrations for this purpose too. So please, during the webinar, feel free to ask your questions. We have a Q&A session planned at the end. So if you have any questions, please type it in any second. We will take care of it and cover it later. All right, so let's talk about first diagnostics in the vehicle lifecycle. Here you can see an extended V model. It's about the classic engineering, and then it's enhanced with manufacturing and service. So usually we start developing the diagnostic in the engineering process, and after that we start using the diagnostics in manufacturing and service. And actually, manufacturing and service of modern vehicles is just nearly impossible without diagnostics these days. So let's start with the first use case. It's a manufacturing one. The use case is inline production. In general, the control computer with the satellites is here. So the satellites are right in the line, and there are only a little number of inline production cycles where the vehicle is powered and the diagnostics are possible. So here you can see some of the different tasks with the respective diagnostics. So if you you can check if you have like the correct assembly of the vehicle. You can also make sure to have the current ECU code and data flashed on the ECUs. And also you can write coding strings according to the ERP, to the enterprise resource planning, and you can set adaptation values. So the next use case is in service. It's about workshops. For one part, workshop in the workshop itself, and the other is when the workshop goes roadside for repair. And there are also many tasks, many different ones to take care of, like locating errors in the vehicles. We also have to repair procedures, and we also have to flash new ECU code and data, read measurement values, and also run inspection routines. So we need a diagnostic tester for sure. It's essential for manufacturing and after-sales services. So typically it contains a big variety of vehicles, many different vehicle types, but also for each type a big number of variants. So the amount of variants is not static. It might kind of change. So there are new vehicles coming to the market. There's new types, also new variants, and also changes of existing variants. And even though we got like make sure that everyone stays the same, we also have like bug fixes in the vehicle variants and have changed parameters and also changed regulations. All right, so those changes, they might cause major effects, effects of like unrecognized errors. So we have two examples of this right here. The first one is in after sales when we have a worldwide rollout. During this rollout, when we have unrecognized errors, they can lead to a month delay, like up to 9 months delay in the whole process. So a huge time issue. The other one is in manufacturing. It's even worse. In a good case, you only have like some cars to rework when the error occurs. But in a bad case, the whole production has to be halted, and that definitely will cause you major time problems and also major cost issues. So the challenge for the tester is we have to test the tester properly. And to perform a regression test, it is essential to have all the vehicles, means types and variants checked. So let's say, for example, we have 10 vehicles, then we have 15 years of legacy we want to cover, and we also have up to 100 vehicle variants per type. So you can see for yourself that's a lot of variants we have to look at. So the result is then you have a lot of people to perform to all those tests, and there are also many different functions in a modern test that has to be taken aware of. You also have to think about a big parking garage if you have to store all the vehicles needed for the device. So the goal is to have a 100% test coverage with all the vehicles, respective types and variants. The question is this possible? Yes, it is possible. We have two components, two basic components that are needed. You see it right here. It's just the test automation to perform the test steps. And also in a second, it's diagnostic simulation that contains all the vehicle types and their variants. In best case, we have test automation control, all the tester function and the respective simulation content. So the concept in detail you can see here. We have the test automation, also the diagnostic simulation. We have two test vehicle types here, type 1, type 2. And you see it's a test hierarchy. It's just an example that might be different in your case then. So the test automation selects one variant like 211 here, and then the diagnostic simulation is active. So you can see the example like this would look like. It's pseudocode. It's test variant 211, and we got a diagnostic simulation starting variant 211, and then we have all the functions like good and bad until we got the proper test result. So let's see how the simulation can look like. Our TCS device is a simulation suite. So the base is the device that is supporting CAN FD Ethernet, and also has an OBD port, as you can see, and a D sub for CAN ECU. So on the left, you see each vehicle variant has an own simulation file, and those files are stored on the TCS. The automation can get control on the simulation device via API. It's called test bench in this case. You can see it's possible to download the simulation, to activate it, to start, stop, and pause the simulation as well. And also you can simulation files can be created with our TCS admin tool. So this one we'll show you later. It's going to be in Dirk's presentation later. And we also have the possibility for manual access to the simulation, and this you can do with the TCS operator. All right. Then you can see the full test assembly. This is a simple example here. You see the test automation triggers a tester function, and the tester function that makes the tester send a request to the simulation, and the simulation will send a response. So this whole process, the simulation process, can be controlled by the test bench API. All right. With this being said, we're coming to the first part of the demo. So this demo will be about the test automation with the simulation. So Dirk, would you please take over here?
Yeah, thank you, Lucas, for the introduction. I want to show you now the full environment. So we have a DTS9 as an example for a test application, and I want to make it full mode here. This is the start page of the test application, and I want to first call the manual tester workspace. It's showing some controls, for example, in dashboard, showing some gauges. If I start the execution of these controls, then you can see there's some live here. It will send some diagnostic request for requesting the measurement values like velocity speed, like the RPM, and some other sensor values. You see there's some action. And you see, this is not only a static value. We have here a dynamic simulation. It's a response with sign-based functions. Maybe I show you also the simulation. So that means we have here, this test application is connected via VCI, controlled by wireless LAN. And this VCI is connected to our simulation device, TCS device. And in TCS device, now there's one simulation running. I can show you the TCS operator. The TCS operator is here, and you can see you can load several simulation files into the device, and then you can decide which simulation shall run. Here you just select the simulation and you can start the simulation. In this simulation, we can control some functions by variables. If I show you the variables page, then you can see if I go, for example, to the engine control module based on the CAN communication, and I just read the variables, then, for example, I can read the DTC count. Here, I just read. And by this variable, we can control how many DTCs shall be sent back by the read DTC by information services. In this case, we get one DTC. So if I check it, I go back to my test application. I go just to the DTC page, and if I now connect the ECU, I read the amount of DTCs, and you can see here's one DTC. For the test automation purpose, I have a script here. I can also prepare my script. I can just I take here my one DTC shall be expected, and so the test passed, successfully read the single DTC. Yeah, on the right side, you can see also there's a bus module. We have real communication on CAN, and here on the test application, we can show the communication. It's also possible that you can show the CAN communication also with our application by TCS admin. Yeah, I can show you some other diagnostic use cases. For example, read the identification service. Here, I just press one button, then it executes some diagnostic services, reading the identification. Here on the top, you can see the big identification number, Softing ECU, and so on. And also this big identification number is controlled by a variable. You can see here, if I go to the correct variable, I read it out. I could change the variable, and if I just read the value once more, then you can see there's the updated value. It's possible also to flash an ECU or also the full vehicle. Herefore, I just decide for the bootloader, the flash container, a small flash container. It takes not so much time. I just start the flashing progress. Now you can see it's working. You can see on the right bus monitor many long diagnostic requests come into the device. We, as a simulator, are not interested in the data. We just confirm the diagnostic request, the 36 service, by sending a simple response. And then the tester is happy with this response. And if I read now the program, the newly updated program version and timestamp, I have to start update the diagnostic service, and you can see here the current timestamp of the last programming process. We can also code our simulated ECU. This is also possible by variable concept that you not that you can also remember the values. So the TCS device can write the newly coded values into variables. And so if a diagnostic service read data by identifier service is requesting, then there will be sent back the actual coded value. I can demonstrate it here. Just to connect the ECU, I can do, where is it? Moment here, I can do the coding, and then you can see here it's successful. And then I already showed you the TTC. Yeah, I think for the first overview that shall be enough. Later on, I show you more.
All right, thank you, Dirk. So the next thing we want to have a look at is how do we create a simulation file. So first example we got here is you can record a trace at the actual vehicle. So the vehicle is connected to the vehicle communication interface, VCI, and sends the data to the tester, and we record a trace here. And what you can do now is with the Softing TCS admin, you can one button click convert the trace into a simulation. Then you've got a simulation file created already, and you can put this simulation file on the TCS device, and it can run like a real vehicle, and it's the same test then. So the base content of a simulation file, how does it look like? You can see it right here with the simulation file. This is just an example how it could look like. There's a simulation for each ECU vehicle, and the file has a communication parameter. So you can see this CAN ID. Every ECU got its own CAN ID, and then the matching communication to it. You can see there are requests, and in this case, some responses to the request, and up to the needed requests for testing the whole ECU, and then it continues with ECU2. So let's look at the functionalities. The basic simulation contains always a request and a response. This means we have a test system which always sends a request, and we also have the simulation, which is the device under test in real life then, and it sends a response. So one example is one request, a normal response. We also have a repetitive response that takes over and over. And also we have requests that only that we can ignore if it's a longer request, so we don't care about the rest of this request. And we also do have like errors. This could be like errors like a wrong identifier, wrong variables, or like a timeout with the wrong time stamp here. So a real vehicle doesn't deliver always static information. It's a dynamic simulation that has to have complex data always. So we have like situations here. So first situation is we have one request and one response. Then we have the same request again, but a different response, which can, for instance, implement a good or bad case scenario. The second situation is we have one request and you see many responses with changing content too. And the third one is in a vehicle, we have many components with rotating parts. They usually can be described via sine and cosine functions, or we have like raw values that are also characteristics of sensors, which are defined by linear or square approximation. And like a change of voltage, for example, can be described in a sawtooth function too. So all these functions can also be incorporated into the response and thus being simulated. So we have variables for diagnostic session handling here. All right, and this part I want to remind you, we have a past webinar from last year, which contains information about this situation. Our colleagues will send you the link right in, so please make sure to check this one too. There are different options to create a simulation file. Like we said earlier, trace conversion is one of them. You also can do an ODX-based creation. What you need is ODX data from the OEM if you have them. You can also do, as a third part, you can do manually adaptation of data to create a simulation. If you have like more sources of data, you can merge simulations. Like if you have trace conversion and ODX-based creation, you can merge these to have one simulation file. All in all, it's an easy creation of simulation. You can easily derivate like variance, and you also have like good coverage of communication mechanisms. So now we want to see in a demonstration how creating simulation files actually looks like, and that's how Dirk will show you.
Yeah, thank you, Lucas. Then I show you the next application. It's TCS Admin. This is a configuration tool for editing, for updating and creating the simulations based on traces or ODX data. And finally, we can also upload some created simulations to the TCS device and bring them to the execution. So what we have to do, we want to create a new simulation based on a CAN communication from the test stand. So therefore, I press the first tile, create new simulation. I give it a new name, or just call it simulation. I want to I have to check the correct communication combination. I want to simulate via CAN1. CAN1 is the CAN channel located on the OBD connector. CAN2 is the CAN connector on the D9 connector. I want to have a simulation process and based on the UDS protocol. So this is enough. I could choose also more than one CAN channel, but I just interested for the CAN1 channel. So here on the first tab, you can see we have communication, a real communication. Therefore, we have to, you need the possibility to manipulate the communication parameters. You can see all parameters are based on their ISO specification. Maybe interesting is here ISO 14229.2 protocol parameter definition. We have here session layer timing enabled. That means that we can define longer response delays. For each response, you can define a specific response delay. If it's too long, then this ISO spec is responsible for sending response pending messages. So you don't have to define the response pendings for your own. You just have to increase response delay, and then dependent on the timing parameters, the response pending messages appear on the bus. The next step is we have to decide which ECUs we want to simulate. Therefore, I add 2 ECUs. So the first one, I give another name. It's, for example, ACM for airbag control module. And the second one could be the ECM, the engine control module. Next step, I have to define the CAN identifiers. For the ECM, it's looking fine. It's 7E0 and 7E8. For the airbag control module, I have to define different values. So I give the proper CAN identifiers 715 and 77F for the identifiers. Yeah, and in the next step, I could import the CAN trace. Then I press import CAN trace. I look for the correct CAN trace. This is a CAN test and drive. This is traced by an earlier session, what you see before in my demo. I open it, and then it will pick out now all diagnostic content of the CAN trace. In this CAN trace, there could be also onboard simulation, but it will skip these messages. It will just take the diagnostic messages. So for ACM, I go to the diagnostic services. There are just some read data by identifier services. For ECM, there are much more communication. And you see there's this diagnostic session control service, the read DTC information services, and there's some read data by identifier services. For some services, you can see there are more than one response. This is now here the multi-response concept, what we used. This was used by the gauges. I could do some adaptations. Maybe I can focus here on the flash service 36. We just have a dot. That means it doesn't matter how many data comes with the flash service. We just confirm the service, and to test the flash progress, we could increase maybe the response delay. Here you can see the delays here on the right. Also, the delays come from the trace file, and you could also, of course, manipulate the delays. You can increase it to test how your tester acts if the flash progress or the flash process takes a longer time. And also you can test the best case. If I set 0 to the response delay, then the device is responding as fast as possible. And you can see we also have inserted some variables automatically during the trace import. I can decide which services are necessary for the coding process. Here are the identifiers 10.03 and 10.04, and also the F1 and so on. are responsible for the coding process, and so the trace importer replaces the bytes by a variable. So this is the advantage is that you can now write the coding values here. This via the write data by identifier services, and then TCS device remembers the correct coding values, and then if you afterwards read sending a read data by identifier service, it will return the freshly written coding value. Here on the variables page, you can see all variables in one page. You can also adapt the values, the start values. And if you think that everything is fine, I think it's fine, then you can load the simulation to the device. So that means I have first stop simulation, update simulation, start the simulation. I could, but I can also choose so I can restart. That means all the steps will be executed in a sequence. So I go. So I just check my status bar. You can see it's now starting, and I have to wait until the status started. So now it started, and now I go back to my test application, and nothing changed here in my test application. So you can see here it's working. So you can see here the dynamic simulation based on our multiple responses. I can also read the fin. You can see this is a previous written value from the fin. I can repeat my flashing. Press start. As you can see, this is the same behavior as before. And if it's finished, then I update my program version, and you can see now this is the current timestamp of the last programming. Yeah, variant coding, as I explained before, it should also work now. I just have to find my do coding button. This is here. Do coding. I can also maybe change to another value. I can say do coding, and it writes and reads the new value here. I go back to this DTC. I read my DTCs. It's one DTC, and maybe in later, if you see that there's something changed in the process, maybe in the new test tool we need 2 or maybe we need 3 DTCs, then you can update your simulation file. I go back to my TCS admin, and I have and now a new CAN trace. There's a CAN trace called 3DTC. So there was just a trace where the testant recorded 3 DTCs. I open this file, and I can just show you what's inside the trace file. There was just the new responses for the DTC services, sending back 3 DTCs. And I would put this new services to my existing simulation. I just have to select both variants. I can say merge, and now if I go back to my VTC command, now you can see the response is extended to 3 DTCs. I can restart now the new simulation, and then we can repeat starting the test script. I'm just interested if it's now started. So it's stopping, starting, and if it started, then I want to repeat my test. 3 DTC, now you can see there's 3 DTC. I can adapt my test. I say now the new result shall be 3, and now the test is passed. So this would be the process. How you acting with tracing the import? You can see it's very easily and very quickly. Sure. Then you can continue with the presentation, Lucas.
All right. Thank you. Thank you, Dick. So, for summary, what have we seen today? The issues in diagnostic tests, they can cause like significant delays and cost issues. We've shown you 2 examples of how could this look like. And it's best to have a 100% test coverage. That must be the goal for the tester test. And also how this goal can be reached. We have to use a test automation and a powerful diagnostic simulation like we showed you in the work together. With all that, we can minimize risk. We can enable you to stick to the schedule, even to tough schedules. If you have a good test coverage, it's possible. And also it will save you a lot of money if you do it right. So with this being said, we are already coming to our question and answer session. I will check if we have any questions yet. If you haven't done so, and if you have any questions, please feel free just to enter in the chat. So I can see we already have a question here. Which trace formats can I use for creating a simulation? Is it possible for Ethernet, Dirk?
Yes. Yes, I showed you just as import of pen traces. Maybe I'll go back to my TCS admin. We have also possibility to import other formats. So not only our Softing own format TRC, we can also import CAN ASC format, but also Ethernet based traces like PCAP, PCAP-NG. So here you can see we can import the Ethernet trace. We can also import other formats like the symbolic trace from our DTS Monaco application and other formats. For the import of Ethernet traces, it's much easier for us because in every frame of the Ethernet, we have the ECU and tester address. And it's so, for this reason, it's much easier than the CAN trace, because here for CAN trace, we have to prepare the simulation, as I told you before, like and for writing the correct CAN identifiers. This step I can skip for Ethernet. So yeah.
All right.
Thank you for the question.
There's the next one. What is the cost of your simulation device and software? Well, that strongly depends on your use case and what kind of data you already have and what you want to do, and also how many users you want to have using your simulation. So it depends on the use case. Please contact me afterwards. You can see my email in just a second, and I will give you more information about that. So there's another one. Is J1939 protocol supported? Dirk?
Actually, yes. Since this year, we have some customers using J1939. So we focused more on J1939 now. So it's possible to make J1939 communication, but also we could also import J1939 based traces. This is possible. So we also support some complex scenarios like DM14, DM15 messages. I think, yes, we support it since this year.
Okay, awesome. So let me check for a new questions. Is there another one? So we will have another minute for questions if some come up. All right. Would say give you another 2 minutes or 1.5 minutes chances to give us more questions. If not, we will go on the presentation, but we are almost through. So in advance, if there are more questions or if you have use cases you want to discuss with us or any business options you are not sure about, please make sure to contact us. Like I'm, as a key account manager, always open for requests for discussion, and also as Dirk, as a as the product owner, he's always up to TCS tasks and for new development. So please let us know. All right. So more questions?
I think there are 2 more questions.
Okay.
Maybe the FAQ.
And oh no, I have to. Well, I will do so. Let's just go back. All right. So I can see them right now. Yeah, okay, there we are. Does the complete suite of software come with the device, or is the software purchased separately? It's separately, but you have to do it on a device. I mean, there is options to do it otherwise, but it's like a well-defined match on those two. So the software comes with the device in the regularly. So it's some use cases we do it otherwise, but in general, the device and the software are complete and not purchased separately.
Yeah, this is a big advantage of our TCS, our predecessor, Tesco 2. You were forced always to use the device together with the software. Now we separated it. Now you can just order the TCS device, maybe with a TCS test bench. If you have some simulation files, you can also just work with the TCS admin, working with simulation files. So you're free in the use. So we have customers who have just 1 TCS device, but 4 TCS admin licenses. So it's free for the customer how to use it.
Exactly. Okay, there's another question. Do you support ZEV on UDS?
Yes, I think this is more a test topic, but of course we would. We already worked with Ceph on UDS. So we worked on the tester side by creating some data, and therefore, of course, we have to create some realistic simulation data. So yes, Ceph on UDS is based on UDS, so we support UDS, and we have already worked with some realistic data on Ceph.
All right. So next one, is the TCS test bench the tool to use to capture trace files?
Not TCS test bench, but the TCS admin could capture trace files. You can, or either you can use TCS, you can start TCS admin, start the trace or the write trace button, and then it would record the trace. But you could also use a TCS device autark. That means you have just to take a USB stick, put it on the TCS device, and then if you prepare the TCS device by TCS admin, then the TCS device is writing the communication either by CAN, NFD, or Ethernet to the device. And then later on, you can create a simulation based on this trace, imported trace.
All right. So keep them coming. If you have more questions, just let us know. We are here for another, I would say, 5 minutes. I think in the meantime, if you have any questions, let's do it this way. We got our email address on the screen right now. Please let us know, give us the questions. If you have uncertain use cases or you're not sure about, just let's talk about it. So we are open to talk with you, to discuss with you. And yeah, I think at this point, I want to thank you all for joining our webinar. It was nice to have you here. Hope to see you in the next one soon. And we will always look for good opportunities to talk with you. So Dirk, any last words from you?
Yeah, also thank you for your interest, and hope to see you and to hear from you.
All right, thank you guys. Have a good time and enjoy the rest of your day.
Okay.
Bye.
Bye.